Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part B, question number 22. The question is, a block of mass attached to a spring oscillates horizontally on a surface. The coefficient of friction between the block and the surface is mu. So which of the following trajectories best describes the motion of the block in the phase space, that is in the xpx plane? 4 plots are given and we need to choose the correct plot. So let's get started. So this question comes from the section Classical Mechanics and the concept involved here is phase space. To describe a mechanical system, both position and momentum are necessary. Only position with respect to time will give you information regarding the path taken by the system, but no information regarding the motion of the system. Whereas only momentum provides the information about the motion or energy of the system, but no information regarding the position of the system. So in order to understand the dynamics of a mechanical system, it is necessary to know both the position and the momentum. And this representation of the dynamics of the system by position and momentum is done by the phase space diagram. So what is this phase space? A phase space is the space of all possible states of a physical system where all the states of the system are defined in terms of its position and momentum. And a state is represented as a point in the phase space. Basically, it is your x versus px curve. In the given question, we have a block of mass m which is attached to a spring, which oscillates horizontally on a surface where there is a friction between the block and the surface. And we need to find out the correct phase diagram plot for this situation. In order to do that, first of all, we will consider the ideal situation of a spring mass system and draw the phase diagram. Then we will consider the given situation and do the modification accordingly. So, first of all, we will consider the ideal situation of the spring mass system in which the motion of the block of mass m that can oscillate smoothly without any friction along a horizontal surface. So to describe the horizontal oscillation of the block in terms of energy, we will do that. So here, as you know, potential energy is related to the position. Kinetic energy is related to the momentum. So, change in both the energy with time will give you the phase space diagram. Here the total energy E is equal to half kx square plus half mv square, where half kx square is the potential energy which is associated with the spring force. K is the spring constant and half mv square is the kinetic energy of the block. So in this case, the energy oscillates between the kinetic energy of the block and the potential energy stored in the spring. Since there is no involvement of the friction, that means there is no dissipative forces. So what will happen here is, at the beginning of the oscillation process, all the energy is stored in the spring of the system as potential energy half kx square. Now as the block starts to move, the velocity of the block increases and the spring gets stretched and the potential energy stored in the spring gradually converted to the kinetic energy of the block. And it is completely converted to the kinetic energy once the block reaches the equilibrium position. So at that moment of time, potential energy will become 0. Now again, the spring gets compressed and the block comes back to its original position and its velocity decreases. So the kinetic energy of the block gets converted to the potential energy of the spring. Once the spring completely rests, the potential energy of the spring is fully restored back and this cycle continues. So when you plot the position x versus the momentum px plot, that is your phase diagram in this situation, here as we have discussed, as the system oscillates, the energy oscillates between kinetic energy and the potential energy, which means both the position and the velocity, or we can say position or the momentum, alternate between the positive and the negative maximum values. When the position is maximum, that is x is maximum, px is 0, and when px is maximum, then x is 0. So the phase diagram will be a clockwise ellipse like this. Now, this is the situation where the block of mass oscillates freely without any friction. In the given situation, we have a frictional force is involved when this block oscillates on the surface. So what will happen in this case? See, friction is a resistance formation. Now, when frictional force is involved, so frictional force means it has a dissipative energy. Therefore, it will create a damped oscillation of the block with each of the oscillator. Now, what happens is, with each of the oscillation cycle, the oscillator loses its energy, which means the amplitude of the oscillation will decrease with each cycle of oscillation. That means both the position and the momentum diminish with time. When this situation is plotted in terms of x versus px phase space curve, it will create the formation of a spiral curve moving inwards. So this will be our resulting plot. Now let's check the option. Now if you check the option, you can see that out of all the 4 plots, option B is matching with our answer. So the correct answer for this question is option B.